All right, in section 5, we're going to look at applying compositions of transformations, and really all this means is it's a combination of two or more transformations. So in other words, maybe we'll translate and then we'll rotate, or we'll rotate and then reflect, or different things. So again, composition just means two or more transformations. And so that's all that says, okay? When two or more transformations are combined to form a single transformation, the result is a composition of transformations. Okay? All this composition theorem, all that says is, hey, after we translate, then rotate, or do any of this, the original figure you start with and the resulting figure will always be congruent. They'll always be the same size. That's what it means to be an isometry, okay? So one specific type of transformation we're going to look at, or composition I should say, is something called a glide reflection. A glide reflection is a transformation in which every point is mapped to a point p double prime by very simply translating first, then reflecting. So a glide reflection means translate, then reflect. All right, so for instance, the vertices of A, B, C are as follows, and so here's what we're looking at. So we'll plot the original. So we have 2, 1. There's A. B is 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. So there's B. And C, whoops, that's B. And C is 6, comma 2. All right, so there's my triangle, my original. And it says first, take this figure and translate it x minus 8 comma y. So in other words, we're just going to move it left 8 units. 1, 2, 3, 4, 5, 6, 7, 8. So there's A prime. Okay. 1, 2, 3, 4, 5, 6, 7, 8. B prime. And 8 is C prime. And so here's what we're looking at now for our second shape. And then finally it says now take that and reflect it over the x-axis. Okay, so down 1 for A double prime. And then let's see here, 1, 2, 3, 1, 2, 3 for B double prime. And C double prime down 2, down 2. Okay, so the final figure we'd be looking at here is the black one here. Okay, the double prime figure. And all this says is, hey, we've taken this guy, we've slid him over, and then we reflected it. Okay, and that's a glide reflection. And remember, this original shape, ABC, and the resulting figure are congruent. So they're the exact same size. So AB would be congruent to A double prime, B double prime, so on and so forth. Okay. Just another glide reflection. I'm sorry, actually this one is not. This is a composition, different kind of composition. So if I plot CD, C is, let's see here, negative 2, 6, so I'm looking at part A first. So negative 2, 6, and D is negative 1, 1, 2, 3. So there's C and D. You could do this a few different ways. You can do it on the graph, or what you could do is you could say, okay, C is the point, negative 2, comma 6, and D is the point, negative 1, comma 3. And so now after the first one, C prime and D prime, we can figure out what those are, reflect over the y-axis. So the y stay, flip the x's, so 2, comma 6 and 1, comma 3. And then we can go one step further, and now we can find C double prime and D double prime without doing anything on the graph. Now we got to take that and rotate it 90 degrees about the origin. So we use our 90-degree rule, so flip-flop, so 6, comma 2, opposite the first one. Flip-flop, 3, comma 1, opposite the first one. And so these 2 points here, those coordinates represent my final image. Okay, so negative 6, 2, 1, 2, 3, 4, 5, 6, 1, 2. And then negative 1, 2, 3, up 1. Those end up being my, let's see here, let me make sure I label these correctly. So this is D double prime and C double prime. So that would be the final image I'm looking for. Okay, and you could do the same thing for B. I'm going to have you guys take a look at B on your own, rotate 90 degrees, and then reflect it over the y-axis. Hopefully you guys can do that, and then have any questions ready tomorrow if there are any. All right, so this next theorem just talks about, it's more double reflection. So it says graph the parallel lines x equals -2 and x equals 4. So x equals -2 would be that line, and x equals 4 would be that line there. Okay? And it says given segment CD, so C is -6, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So there's C, and D is -4, 3, 1, 2, 3, 4, 1, 2, 3. Oh, I'm sorry, -3, 1, 2, 3, 4, 1. So C and D. So there's my original segment. And now let's see here. What do they want us to do? They want us to first reflect over the x equals -2 and then over x equals 4. So if I reflect over x equals -2 first, I count 1, 2, 3, 4. 1, 2, 3, 4. So that would be C prime. Start at D, go 1, 2, 1, 2. There's D prime. Okay? And then the last step is to now reflect it over the line x equals 4. So again, 1, 2, 1, 2. There's C double prime. Let's see where we're at here. 1, 2, 3, 4. 1, 2, 3, 4. There's D double prime. And so that final segment there, the red one, is our resulting image. Okay, and so you'll notice a couple questions here. Number one, compare CD with C double prime, D double prime. What type of transformation results from reflecting the segment over two parallel lines? You'll notice once you reflect it over both lines, right? I could have easily gone from the original CD to C double prime, D double prime by simply translating, just sliding it over. Okay, so when you reflect over two parallel lines, it's the same as just translating. Okay, I'm going to try to keep it up here as much as I can. So part 2 here says, now look at the distance between the two parallel lines. Okay, so first, if I look at the distance from this point to this point, that's the distance between the two lines. It's 1, 2, 3, 4, 5, 6. So the distance between the two parallel lines is 6. Now it says compare the distances from C to C prime and C to C double prime and D to D double prime. So here's D double prime. So I got to just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the distance here is 12, and then I go from C up here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that distance is also 12. And so the relationship is that the distance from the original figure to the new figure is 2 times the distance between the parallel lines. Okay, and that is the relationship. If you reflect over two parallel lines, it's the same thing as translating by twice the distance between the parallel lines. Okay, and so here's that theorem. Okay, if I translate over two parallel lines, then the distance is 2 times D, where D is the distance between the parallel lines. Okay, and we'll use that to solve some problems. So for instance, it says in the diagram a reflection in line K maps GF to G prime F prime. A reflection in line M maps G prime F prime to G double prime F double prime. And we know that FA is 6. And we know that D to F double prime is 3. We got to answer some of these questions. It says name any segments congruent to each segment. Okay, so GF. Well, G prime, F prime are congruent, and so is G double prime, F double prime. Okay, because again, those are isometries. We're just reflecting; they got to be the same length. And then I look at the distance from F to A. Okay, the distance from F to A is really going to be the same as the distance from P to A. Okay, so those two lengths are going to be the same. That's not really anything that we're going to talk about directly, but just something just an observation to be made. And then the distance from G to B is the same as the distance from G prime to B. All right, and that's really what they're wanting you to notice. Okay, and there's actually more relationships going on there, but I'm not going to get into all those discussions. Okay. It says, now this part B is one that should make sense. It says, does AD equal BC explain? So does AD equal BC? The answer would be yes. Well, how do I know that? Well, we do know that these two lines are parallel. And so I know that when I reflect over the two lines, okay, that the distances between these two parallel lines has to be the same. Okay. Now, in theory, when I look at this, I would have to argue that I can't say that they are the same, because this would have to be perpendicular, okay, in order for us to say that. We don't know if it is or not, so we can't assume that. So anyway, so in these different diagrams, all you're going to have to really be able to do is, if I tell you that this length here, AD, is 6, and I say what's the distance from F to F double prime, you should be able to tell me that's 12. Okay, that's really what it boils down to. I don't want to get too far into this discussion. That's kind of what this one asks here. Okay, it says what's the length of G to G double prime? Well, we know that. Let's see here. We know that FA is 6. So where's that at? This piece is 6, and we know that D to F prime. So D to F prime is 3. Okay. And so now what we look at is we know that if that's 6 and that's 3, this middle piece has to be 9, because again, that distance is going to be 2 times as much. All right, so the distance is very simply going to be 18. All right, and then lastly, reflecting over intersecting lines. Okay, when you reflect over intersecting lines twice, it's the same as a rotation. Okay, and so when we look at this diagram, if I take AB and I reflect it over the first line, I get A prime, B prime, and then I get A double prime, B double prime. All right. Then what you do know is if this angle is x degrees, then the angle of rotation would be 2x degrees. All right. That would be to take AB all the way over to A double prime, B double prime right away. Okay. Where x is the measure of the we'll just say the angle, okay, meaning the angle between the intersecting lines. And so that's what we're looking at there when it comes to that. So again, if you're reflecting over intersecting lines twice, you can just find the angle in the middle, double it, and it's the same as a rotation by that angle measure. So for instance, it says the image is then let's see here. In the diagram, the figure is reflected in line K, and then it's reflected in line M. Describe a single transformation that maps F to F double prime and A to A double prime. So in other words, if I reflect over this one first, and then over this one here, and the angle here is 80, then what I could say is to go from F to F double prime, okay, what we could have done is just rotated, that's 80, so I have to double that. So I could say rotate 160 degrees counterclockwise to the left. Okay, over here, now you got to be careful because the angle has to be acute. Okay, find the measure of the angle. The angle when they intersect, you got to find the acute angle. Okay, I should have mentioned that up there. So in other words, when I look at this next diagram, excuse me, when they intersect, this guy's 99, which makes this one here 81. And so when I do this double, when I find this rotation, I got to use the 81. Okay, so this would be a rotation of 162 degrees counterclockwise. So again, when you're doing this, when you're working with this relationship, you have to identify the acute angle. Okay, can't be over 90 degrees. I know these last two theorems are a little bit obscure, kind of different, but again, just to kind of get your feet wet, and then we'll look at them a little bit more tomorrow. And again, as always, questions will be answered first thing.